lesson 4 of chapter 7 of Probability and Statistics. Our topic today is tree diagrams. The essential outcome is that you will be able to create tree diagrams and find probabilities of the branches. So, quick refresher, what's the difference between theoretical and experimental probability? Pause the video now and see if you can write down what the difference is. Alright, remember, theoretical is what should happen. Theoretical is the desired outcomes over total outcomes. Alright, experimental, you do the experiment. It's the number of successes over the number of trials. Success over trial. Alright, so today we're going to be talking about some tree diagrams. So, first off, a tree diagram, what is it? It's a way to model chance behavior that involves a sequence of outcomes. So, we're going to make a tree diagram that depicts the tossing of two coins. Alright, so what we first do is we start off at the front of this tree diagram right here. And so, at the very beginning, when we toss our first coin, we have two options. We can either get a head or a tail. So we put those in heads, tails. And what we actually do too is we write the probability of these events happening. Each branch, so the probabilities right here in this front column should add up to 1. And so the probability of getting a head is 0.5. The probability of getting tails is 0.5. So that was our first coin flip, but we're flipping two coins, remember? And so now when we flip our first coin, well, then when we flip our second coin, we still can get heads or tails. And on this flip, it's still, once again, the probability of each of these is just going to be 0.5. Alright? It's the same thing. Down here, we get heads or tails, 0.5, 0.5. And so then, now what we can write is we can write the outcomes. We would get heads, heads, and to find the probability of that, we take the two probabilities on the branches and we multiply them. So we take 0.5 times 0.5 and we get 0.25. Here we got a heads and then a tails. We take 0.5 times 0.5, we get 0.25. We had tails and heads. 0.5 times 0.5 gives me 0.25. And then we got tails, and 0.5 times 0.5 is 0.25. Things to notice. Right here we should have all the different possible outcomes. Here we have the probabilities of each event, and these should add up to 1.00. When you add them up, you should get 1.00. If you add all those up, you do get that. So, things to notice. Each branch must add up to 1. We talked about that. This first branch, the probabilities added up to 1. These branches, the probability added up to 1. Probability added up to 1 here. Alright? Secondary tiers should be the same on top and bottom branches. What that means is that we continued the same pattern. We did heads, tails, we did heads, tails, we did heads, tails. Alright? And then compute the probabilities of final events by multiplying individual events together. So we took those probabilities of each of these different events. We took the probability right here and multiplied by the probability right here to get the total outcome. So something to think about is what would be different if you asked for 3 flips of the coin. If you're asking for 3 flips of the coin, we have our first flip, our second flip, we would have to do another set of branches for our tree. So we're going to add 8 more options. And that is a tree diagram. So here we have sports and graduation rates. So here are a few different probabilities. The probability a student is in sports is 0.22. The probability that a student graduates knowing the student is in sports is 0.92. The probability that a student doesn't graduate knowing they aren't in sports, and that is 0.18. So what we're going to do is we're going to use a tree diagram to depict all the scenarios of a student being in sports and graduation. So, first off, let's start off with probability that a student is in sports. So, we start off our tree diagram. Alright, and we get sports and not sports. Let's type those in. Sports, not sports. Remember, we know that the probability that the student is in sports is 0.22, so we can put that probability right there. Alright, so if the probability is, we need to know the probability the student is not in sports. Well, remember, each set of branches needs to add up to 1. And so to find the not sports, we would actually just take 1 minus 0.22. So pull out your calculator. You can't do that in your head. 1 minus 0.22, and you get 0.78. So the probability that a student is not in sports is 0.78. Alright, now our next branch is going to be graduating. Alright, and so we have to do that for each of these, remember? We're going to do it here, and we're going to do it here. So we're going to start with the probability that a student graduates and the probability that they don't. So we're going to call graduation just the event G, and if they don't graduate, we're going to use our not designation, which is either that C or that prime. I'm going to use a prime. So G prime. They don't graduate. Alright, so we've got a few things up here that we know. We know the probability that a student graduates knowing the student is in sports is 0.92. So here we have the probability that a student is in sports and they're graduating. That probability goes right there on our branch. Now remember, these branches need to add up to 1, so if that's 0.92, we do 1 minus 0.92, and we get our not graduating, and it's going to give us 0.08. We do the same thing down here. We're going to have the probability that they graduate and the probability that they do not graduate. Alright, so the probability that the student doesn't graduating knowing they aren't in sports. So, doesn't graduate knowing they're not in sports, that's where that goes. We're right there. If that's 0.18, we do 1 minus 0.18 to get our probability up here, which is going to give us 0.82. Alright, and there we have our tree diagram all filled out. So now let's answer some questions. Some additional questions. When selecting a student from the entire student body, what is the probability of the student having the following characteristic? What is the probability that a student graduates? Alright, so to find the probability that a student graduates, we first need to find out all these different event probabilities. So, remember, we multiply through to get them. If we go 0.22 times 0.92, those are our graduating students, we get 0.2024. Here's our other graduating students right here. So we take that probability in that first one, 0.78 times 0.82, 0.78 times 0.82, you get 0.6396. Alright, and so now we have, those are our two graduating populations. So if we add those two numbers together, we will get our probability that our student graduates. So if to get this probability right here, we need to add this number and this number together. We add those two numbers together, we get 0.842. There you have it. So what is the probability that our student does not graduate? There's a few ways we can do this. We can do it the same way we did it there. So let's do it that way first. Now we find the probabilities of our students not graduating. So we go back. We take the sports probability, 0.22. We multiply it by the not graduating probability, 0.08. And we get 0.0176. We do the same thing down here. We take our not sports, 0.78, times our not graduating, 0.18. We get 0.1404. So if we add up those not graduating probabilities together, we're going to get our total probability of not graduating. It's 0.0176 plus 0.1404. We get 0.158. One thing to notice, 0.158 should, and 0.8142 should add up to 1. And so, if I did this correctly, they should add up. So, we need another probability now. We need the probability that they play sports and don't graduate. So, if they're going to play sports and they don't graduate, we already found that probability. It's right there, 0.0176. What's the probability that they don't play sports and they do graduate? So, not sports, but they graduate. That's 0.6396. Alrighty, and that is the end of lesson 4 of Probability and Statistics of Chapter 7. Write your summary and your questions. The essential outcome for today was that you'll be able to create diagrams and find probability.